Hello and welcome to today's webinar, MPLS, SD-WAN and Cloud Networks, the path to a better, secure, and more affordable WAN. A couple of housekeeping items before we get started. You're welcome to submit questions at any time using the chat window on the right-hand side of your screen. We will follow up with you after the webinar. We'll also make a recording for this webinar available to you within a couple of days. It is my pleasure to introduce today's speakers, Dr. Jim Metzler and Yishai Yovel. Dr. Jim Metzler has worked in many positions in networking industry and is now running a consulting organization. He has written for numerous publications and is a frequent speaker at conferences and seminars. Yishai Yovel has over 25 years of experience in defining and deploying enterprise IT software solutions in the area of security, storage, business continuity, and mobile computing. But first, let's run a quick poll for us to get acquainted. So the first poll for you guys is, what technology are you using for your WAN? Okay, see some great results. Okay, closing up the poll now. So let's just share the results. So I see about most of the people here use MPLS, VPN tunneling over the internet, and the rest. Yishai, maybe you want to comment on these results?
Well, obviously, this webinar is about the evolution of the WAN technologies, and the two top answers are the current state of the WAN, and the other options are the evolution, and this is what we will discuss today.
Okay, great. So, passing on the control to you, Jim.
Okay. Eden, thank you so much. I'm very excited to be here today to talk about what I think is one of the most important topics in our industry, and that is the wide area network in our era of mobility and cloud. Quickly, the agenda. I'm going to spend just a couple of moments with some background thoughts on the wide area network and how we got to where we are today. Then I'm going to discuss three different approaches: a legacy branch office network, one application of SDN in the WAN, a secure cloud network, and then I'm going to end with just a brief summary and call to action. So let's get started. When I think about the wide area network, well, starting back in the mid-'80s, there was a wide range of development. Certainly, the Internet and the World Wide Web has played a major role. Now, the Internet actually was developed in 1969, the early 70s, but didn't really become the rich, heavily used entity it is today until the World Wide Web in late 80s, early 90s. And we had a sequence of enterprise activities around time division multiplexing, X25, frame relay, which was...
Hey, Jim?
Yeah.
Jim, sorry for that. Can you just, we don't see your slides.
Oh, I'm sorry.
Have some kind of a play button?
Okay, great. Thank you so much.
Okay, great.
Guy will pick up from what I was just talking about, which is starting in the 80s, you went through a sequence of changes in the wide area network. The Internet enhanced with the World Wide Web, time division multiplexing, X25, and a follow-on technology of frame relay. There was significant discussion of deploying a service or a technology called switched megabit data service. Never happened. There was a lot of discussion of asynchronous transfer mode, ATM, that some people were referring to as your next and last technology. It got deployed, but not as broadly as anybody thought. And then around the year 2000, we began to deploy MPLS, multi-protocol label switching. I suggest that since around the year 2000, other than cellular, the deployment of 3G, 4G, and now we're looking at 5G, the WAN has been very staid. For example, there's no successor to MPLS in the pipeline, and we're not going to see one. So we really have two primary services, the Internet and MPLS today. And when I think of the characteristics of WAN services, I think of them being expensive, complex, and inflexible. Now, in my presentation today, I'm going to present 4 or 5 slides of some recent market research. This is based on a survey I gave to a couple of hundred IT professionals. And one of the questions I asked was, what factors would drive you to change your wide area network? Now, typically cost bubbles to the top when we're talking about the wide area network because we have this monthly recurring charge from each one of our branch offices, from our data centers, on and on and on. And yes, 24% of the respondents said the cost is important. But that same percentage said it was important to support mobile users, and a few more said it's important to provide access to public cloud computing services, and hence the title of my presentation today, Wide Area Networking in an Era of Mobility and Cloud. If we stay with the slide a bit, if you look at the first and third histogram there, you're saying, yes, I've got to cut costs. Yes, I have to worry about mobile users in the cloud, but I still have to be able to do application delivery in an acceptable way, whether that's for a real-time application or not. And in this era of increasingly sophisticated security hacks, I need to always be concerned about doing all of this in a secure fashion. Now, this slide's about a topic that I think is incredibly important and we don't talk enough about in our industry, and that is the ability to rapidly identify a problem and fix it. And I surveyed, again, those 200 professionals, and I said, how much visibility do you have today? And if you look towards the bottom of this chart, 17%, that's less than 1 in 5, said we have all the visibility we need to effectively troubleshoot problems. 1 in 5. A few more said the visibility we have is barely adequate, and everybody else is kind of in the middle. This is a very important slide. We will not do good things for our company. We will not do good things for our IT organization, and we will not do good things for our own careers if we can't get better at troubleshooting. So it's any WAN technology or service that we're thinking of adopting. Yes, we have to evaluate the technology and the service, but part of that evaluation has to be, do I have the tools to troubleshoot a problem? Because we know there will be problems. Now, as I say, I want to talk about a few different approaches to wide area networking, starting with the traditional branch office WAN. In this environment, users reside in a branch office, and they communicate in that branch office over a wired LAN. They're connected to the organization's data center using an enterprise service like Frame Relay or ATM or MPLS. And there are some important advantages to this approach. It's well understood and it's stable. MPLS, for example, has been out for 15 years. So again, well understood and stable approach. But there are also some key disadvantages. We just saw how important it was to support mobile users, and this approach does not do that. And I'll get into it in a little bit more detail on the next slide, but internet traffic typically is backhauled. By that I mean it transits the company's MPLS network, gets to a data center, and is then handed off to the internet. This slide reflects how much traffic actually is backhauled. If I look at that green piece of the pie on the left and the dark blue beneath that, the dark blue says that 10% of companies backhaul between 61 and 80% of their traffic, and the dark green says that 40% backhaul 80% or more, actually more than 80%. Taken together, that says half, 50% of companies backhaul more than 60% of their traffic, their internet traffic. Now, if you only have a little bit of internet traffic, no big deal. Don't worry about it. But I don't know very many companies that only have a little bit of internet traffic. My clients typically have a lot of internet traffic, and it's growing. And the problem with backhauling it is you pay to carry that traffic twice. You pay to carry it in the MPLS, and then you pay to carry it on the internet. And you get double, if you will, or you get delay from both the MPLS network and you get delay from the internet. So you pay twice and you get more delay. Again, possibly acceptable if you have only a small amount of internet traffic, but definitely not acceptable if you have a significant amount. As part of that survey I mentioned, I asked people to indicate what their concerns were with wide area network services. And if you look at this table, the concerns are listed from the most important downward. So under MPLS, the most important concern was cost, then uptime, then latency, then lead time to implement new circuits. I doubt if it's a surprise to anybody on this webinar that cost was the most important concern relative to MPLS, and the security was the most important concern relative to the use of the internet. One thing that says to me is, as we look going forward at deploying new WAN technologies and services, we have to think about how we reduce the amount of money we're spending on MPLS and how we can increase the security of anything that transits the internet. So getting back to the agenda, I now want to talk about one use case of applying software-defined networking, SDN concepts, in the wide area network. And I'll put this in perspective. As recently as, say, 2.5 years ago, if I said SDN, software-defined networking, I didn't bother saying SDN in the data center. I didn't bother because it was implicit. Until relatively recently, when we said SDN, we meant in the data center. But there's been a big change in the last just 18 months, maybe 2 years. And as this particular chart shows, when I surveyed people and said, hey, where are you interested in applying SDN? 51% said, Jim, we're looking at applying it in the data center. But 31% said we're interested in applying it in the wide area network. And another 20% said we're likely to implement a service from a WAN service provider that's based on SDN. And even get back to that first survey, 10% of the respondents said they've already implemented or are using an SD-WAN, showing that there is this interest building up in applying SDN in the wide area network. Now, one use case of SDN in the wide area network is focused on the one that we talk almost exclusively about, is for branch office SD-WAN. It is focused by definition on connecting branch offices. And as part of the SDN architecture, it separates control from forwarding and has end-to-end encrypted virtual overlay. So there's an element of security here in the encryption. You can either do it on a DIY, do-it-yourself basis, or acquire a managed service. And a big part of the value proposition, a big part, is this policy-based dynamic load balancing of traffic over multiple WAN links. So one example, I've got an MPLS link and I've got an internet link, and I'll choose dynamically which traffic is most appropriate for the MPLS link and which traffic is most appropriate for the internet link. Now, there are some really key advantages to this approach. It can reduce or cap WAN costs. So I might decide to pull out some of those relatively expensive MPLS circuits and replace them with internet bandwidth. I may just decide, well, I'll leave them in place, but I won't add any more of the relatively expensive MPLS circuits. Any new bandwidth will be relatively expensive internet bandwidth. And this approach also centralizes configuration provisioning, making those two key processes easier. Unfortunately, there are some key disadvantages. It doesn't support mobile users, and we saw again on that survey how important it is to companies to support mobile users. And there's no control of the middle mile. So hand it off to the internet, and you get whatever delay, packet loss, jitter, etc. you get on the internet, which means the it's becoming that much more difficult to ensure acceptable application delivery. And again, we saw how important that was. And there's no integrated, sophisticated security. Yes, there's encryption, and encryption is an important thing, but there isn't more sophisticated functionality like URL filtering, for example. Now let's move on to the third of the three types of networks I'm going to talk about, and that's a secure cloud network. The first two bullets on this slide are just intended to reinforce something everybody on the call understands. The use of public cloud service providers is large today, and it's growing. One measure of such, IDC, says the use of these services is going to grow at roughly 20% per year, from 70 billion to 141 billion. And why is this growing? Because the use of public cloud tends to reduce complexity, cost, and time to value. And that raises a very important question. If we're using public cloud for all these other applications and all these other infrastructure services, why are we not at least considering using a cloud-based solution for security and for networking? And with that in mind, when I use the phrase a secure cloud network, I think of a network that connects mobile users, branch offices, private data centers, public cloud providers. And getting back to that slide that I had before on visibility, in which does this and provides full visibility into all traffic. Because nobody on this webinar today will be successful rolling out a new service or a technology in a wide area network if they don't have the capability to effectively troubleshoot it. You really don't want to go to your boss and say, hey boss, good news, bad news. Good news, I saved us some money. Bad news, when some of the company's key applications aren't running well, I have no idea why. That's not a good conversation to have. And as part of the secure cloud network, you should expect and demand integrated security that enables a unified policy across all asset types. And as part of the general idea of moving to a secure cloud network with no additional point solutions, whether that's in the security sense, firewalls, IDS, IPS, optimization, whatever. One of the reasons that I said early on that the WAN is complex is we have all these point solutions doing individual tasks. We need to move away from that if we're going to truly have a new wide area network. Now, when I think about a secure cloud network, think of a number of points of presence, number of POPs around the world that are connected in kind of a CDN, content delivery network type approach. Again, eliminating branch office products. And I mentioned the importance of minimizing latency so we get better application delivery. And one way we can do that in a secure cloud network is to have multiple tier 1 carrier backbones and leveraging one versus the other. And we saw how important application performance was. So you should expect functionality like forward error correction or application throttling. So we do get acceptable application delivery. And one of the issues with MPLS was the long lead time for new circuits. Well, let's take another approach and just be able to add internet capacity quickly. Security, we've been talking about how critical that is, and that's not a difficult point to make. Everybody out there knows that. So yes, we want to provide access via secure tunnels. That's kind of table stakes. But you really want to have security built into the design of the service, not a bolt-on, not one more point product over here or there. And by integrating it in, you should expect functionality today like next-gen firewalls or URL filtering, but at least as important as to what functionality you're getting today is the ability of that service to provide additional security functionality over time. Now, a very brief summary, call to action, and then I'll be very excited to hear what Kato Networks has to say on this topic. Folks, it's not difficult to drive home the fact that for the past decade, the WAN has been very staid. Okay, 3G, 4G, 5G might be an exception, but that's it. It's also not difficult to say and to assert that a current or a contemporary WAN design needs to be able to support mobile users. It needs to be able to support still the branch office, private and public data centers. That's what the WAN is today. It's no longer this kind of closed system of branches talking to private data centers. That particular use case is so popular today about an SD-WAN, and it's a wonderful use case. There's nothing wrong with it, but it's focused on the branch office. It does not support mobile users. A cloud secure network, again, leverages all of the advantages that we've seen across the board from cloud services, and it does that in a way to improve app performance and to reduce internet latency, and those two are related, obviously. A unified policy across all assets, the ability to quickly add capacity, and to do such in a way where security is integral to the service, so you get sophisticated functionality today and the ability to add more tomorrow. Now, having said that, I really am anxious to see what Kato Networks has to say on this very important topic.
Okay, Idan. Okay, thank you very much. Pass with control. Okay, hello everybody. I'm very happy to follow Jim's great overview of the current trends in wide area networking. I'm going to be talking from the perspective of the secure cloud network, which is Kato's offering. What I'd like to do first, though, is to really discuss kind of why the secure cloud network is really an expansion of the vision for next generation WAN. So there's a lot of talk in the market about SD-WAN, but I want to pose kind of three questions. One is the internet versus MPLS kind of scenario. So SD-WAN comes in, it keeps the MPLS leg, it adds internet, and it provides offloading, but the internet leg has built-in challenges that Jim described, the unpredictable routing, the packet loss, the latency. So the question is, will we always have to pay for MPLS? Is there any kind of vision for the beyond the MPLS world? So that will be the first point. The second point is that we need security everywhere the network is. So why don't we just integrate or converge networking and security? So other networking technologies really try to focus on networking problem, but security and networking is really tightly converged in terms of our network design, in terms of the solutions we deploy. And the last point is that is the one really about branches, right? So we're doing all this great redesign of our WAN. We better connect our branches through a combination of MPLS and internet links. But what we need to do too is to integrate our cloud infrastructure, so Amazon or Azure, as well as our mobile workforce. So how do we get our future WAN to address those scenarios too? So really, it's not about MPLS cost reduction. It's an important value proposition, but the strategy for the WAN really goes well beyond this particular driver. So if we think about, when Kato thought about the secure cloud network, we came to the conclusion that the fundamental issue is that we used to have a simple network design because we had a very clear network perimeter. Assets were either inside the network or outside the network. Initially, everything was inside. So we can secure it with a firewall or some kind of a solution like that. And now what we have is a dissolving perimeter. We have data, people, both inside and outside the perimeter. The perimeter is gone. And when we are using the hardware-based network security solutions, they're really designed to protect clearly defined perimeters and not this convoluted mess that we have today. And this kind of manifests in a lot of very obvious way in the enterprise. We want to secure branch offices. We can either put a firewall there and then build a bunch of VPN tunnels over the internet, which then introduces latency and unpredictable performance, which Jim referred to. Or we backhaul traffic, we save the footprint in the office, but we kind of get the trombone effect. We go out to the internet, we come back to headquarters, we ship data back to the branch office. It's not a great way to do things, especially when the percent of internet traffic is really substantial. And then we go to the cloud. We have cloud infrastructure. We have cloud-based applications. The security solutions we have today are not really compatible with these environments, so we need to deploy more point solutions to cover those, so the complexity and the cost increases. And finally, we have a mobile user that basically can take their BYOD device and go directly to the cloud. They bypass our network security stack, so we have to go and address that scenario too. So this is what the dissolving perimeter is causing the network. So the security problem that is manifested in this slide is actually a result of a broken network topology, which is created by the needs of the business to do more cloud and more mobile. And this is coming on top of an already complicated environment. So we have appliances that needs to be bought, deployed, repaired. They run out of capacity. We get a bigger one. They can only cover a piece of the network, so we need to deploy them everywhere. We need people to run this infrastructure, and because it's hardware and software combos, we have to update them. So you're all familiar with Patch Tuesdays. We are falling behind on vulnerabilities that are found in those solutions, and then of course they're getting exploited. So the basic economy of appliances coupled with what's happening to the wide area network topology creates a very complicated scenario for most enterprises. So I'm going to stop here and let Idan ask one more question, and then we'll continue.
Okay, so here's our second poll. What is your biggest network security challenge? Okay, just wait a few more seconds for everyone to vote. Remember, you can choose only one answer, so you need to pick what is most painful for you guys. Okay. 5 more seconds. Okay, let's just share now the results. Mishai?
Okay, yes, so it's kind of very interesting. The top challenge here is network latency between locations. This is kind of the one thing that we can't really do much about unless we spend a lot of money on MPLS. So I think that's an obvious challenge. Direct internet access is just the result of the cloudification of the enterprise and the need to go to the internet without backhaul. I think that's an obvious use case. By the way, what's embedded here is a security challenge, right? We need direct internet access. It's not because we can't get to the internet, but we need to get to the internet securely. So we backhaul to a central security infrastructure. That's kind of the point that we're trying to make. And the other challenges are really more, a perspective on the new stuff, AWS, Azure, mobile. Appliance sprawl, if you ask me, I think it's more of a compartmentalized, or we kind of don't want to think about that. We just run it. We used to run it. Maybe we don't give a lot of thought to what it cost us. So we'll just continue from here. I'll just proceed with the presentation and talk about the solution. So what do we actually proposing? So what Kato is basically, the premise of the company is that we want to take networking and security to the cloud because appliance-based infrastructure is simply too complex and too costly to own in this new era of mobility and cloud. And what's unique about what we're trying to do is that unlike many solutions, they just add stuff to your plate, so they give you value, but they require you to manage more things. What Kato is trying to do is to simplify your environment so there is less stuff to manage and not more stuff to manage. That's a very simple objective that we have. And so how do we do it? So since we have identified the topology of the wide area network as the root cause of a lot of the challenges that we have in securing this new network, We're taking the different network elements, the headquarters, the data centers, the branches, the cloud infrastructure, the mobile users, and we connect them to a new perimeter in the cloud. Essentially, we are reestablishing the dissolved perimeter in the cloud, and we run through that perimeter both the wide area network traffic, so the traffic between those elements, and the internet traffic going to the internet. So that's the first step. The second step is that once we have this traffic consolidated in the cloud, we can apply a set of cloud-based security services. And we build them directly into the network. So it's not two separate things. It's actually one thing that is both a networking platform, which has built-in security. And I'll talk about those services in the next couple of slides. And finally, as we have both networking and security integrated, we now have an opportunity to enforce a unified policy across all assets. So we don't need a mobile security solution to control access between a mobile user and a cloud. We don't need to put a cloud access control solution just to control access between the business and cloud services, etc. So instead of basically providing or deploying point solutions to address different scenarios, depending on the source and destination, we can actually enforce a unified policy. So let's talk about how we do it. Right? It's a great vision. Let's talk about the details of how this is actually achieved. So what we've done at Kato is we've deployed a global network of points of presence, which runs our integrated software stack. So we basically built, purpose-built, an integrated stack that has both a network layer and a security layer, which is running on standard servers in POPs that we have deployed globally. We have interconnected those points of presence with multiple tier 1 carriers, which are SLA-backed. It means that we can run a packet from one side of the world to the other on a dedicated link provided by that carrier. So we actually minimize the latency. We're not subject to the random routing and congestion conditions that apply to the internet as a whole. Okay, so this is essentially a way to achieve a low latency routing of traffic without actually deploying MPLS circuits. That within this network backbone, we provide a lot of very powerful services. First, we're doing routing. So there are no routers in our infrastructure. It's all done in software. We ensure reliability through forward error correction. We optimize the traffic using multiple algorithms that handle different applications. And we, of course, encrypt the traffic on that backbone end-to-end. So this is the backbone, which is already a step up from where internet connectivity is. So if you're a customer using VPN tunnels between firewalls over the open internet, this kind of an infrastructure is already giving you a leg up versus where you are. If you're an MPLS customer, we can actually use that infrastructure, which is internet connectivity based, to lower your MPLS cost. How do we connect to this backbone? So we basically provide multiple connectivity options. If you have a large data center, you have firewalls there, you can build an IPsec tunnel from that firewall to the backbone and to the nearest POP. And the traffic will be forwarded, all the traffic from that location that is going to the wide area network or to the internet will go to the POP. If you're within a branch office when there is no firewall, we provide Kato Socket. It's a very small appliance. It's included in the service, and it has one function: to move the packets from that location to the nearest POP. It has no business policies, no business logic. Everything is done in the cloud. It's simply a forwarding device. We have a virtual version of that we can use to connect a cloud data center. So if you have a bunch of servers in Amazon AWS or Microsoft Azure, we can actually connect those subnets to the backbone and immediately provide access into those servers from any other network element. And finally, we provide Kato clients for Windows, Mac, iOS, and Android, which will connect your mobile users through a VPN tunnel, essentially, to the nearest POP. So if users are traveling across the world, they always connect to the nearest POP, and their traffic is traveling across our optimized backbone. Compare this with using a VPN client from Japan to connect to a firewall in New York to get to the data center. You're basically routing your traffic over the open internet, which causes a lot of latency issues, and everybody knows that this could be a very bad experience. Regardless of which POP, physical POP you're connected to, we're abstracting the wide area network into one logical network that the customer can actually manage. Okay, so this is the network layer of the solution. Let's talk now about security. So what we're doing for security, as I mentioned, since we have all the traffic consolidated on the backbone, we have built a next generation firewall directly into that backbone. So we can inspect every packet that goes through from the packet up. So we have the ability to detect applications regardless of protocols, etc. And again, this refers to any kind of application, both applications used on the WAN and applications that are used on the internet, so such as cloud applications. We have built-in URL filtering capability, which allows you to filter URLs. And all of these services, and I'll talk about our roadmap in a second, they're all fully elastic and agile. You don't have to think capacity planning anymore in terms of your firewall sizing. So you don't have to think about different models of what you will deploy on-premise. You don't have to think about upgrades or growth. If you're connected to the services are available to you, and we deal with both the elasticity of the service, the scalability of it, and of course, we manage the software. So you get features added seamlessly. We patch vulnerabilities, even if we have them. We can actually take care of them very, very rapidly, so you're not exposed. Now, as Jim mentioned, there's actually an opportunity here to roll out a lot of capabilities, and again, seamlessly. So we are adding, in the next 12 months or so, we're going to roll out additional capabilities. Cloud access control, basically controlling access to specific areas within cloud applications. Network forensics, we can hand off packet streams to third-party capabilities that you may need, or use it ourselves to do basically threat research. We're going to integrate infection prevention, including anti-malware, sandboxing, and we're going to do extrusion prevention. So basically looking at all the traffic going out of the system for both data leaks as well as attempts to communicate with command and control. What's important about this infrastructure is that doesn't require any action on your part other than applying policies. Those capabilities simply show up at a very rapid pace, and we can enhance them very quickly without requiring the customers to take any action. So this is the integrated security stack. Again, all software, it's all stuff that we have built from the ground up, and we're making tactical decisions to integrate certain capabilities. So for example, for the URL filtering, we will integrate a database of a URL classification, but the actual enforcement and analysis is done by the next generation firewall. So we handled security. What about policy? So we provide a cloud-based console that you can go in and manage the environment. And there's actually a great way here, both for the enterprise IT to go and individually look at their network, for an MSSP or an MSP partner to go and manage multiple networks without the need to reach into the customer environment and manage specific firewalls in specific locations. And of course, Kato itself is using it to monitor the overall health of the service. But I think what's the most beneficial thing for the business is the ability to see everything that is going on, so really understand the usage of the network, the access to the applications, shadow IT type scenarios, and then immediately turn back and enforce policies, if necessary, across the entire business to address scenarios that are evolving within the business. Okay, so this is the policy aspect of the solution, the manageability, the visibility, which are really really big challenge for enterprises today. Couple more slides to wrap it up. Some people ask us, that's why I spend time on it here, how come nobody had done it until today? Why is it that this sounds like a great idea? What's happening now that actually enables a company like Kato to exist? And there are some trends that happen, mega trends, that are really enabling us to deliver this service to customers. The first is that the internet has drastically evolved in terms of its capacity and its prices. So for example, as a result of the massive increase in DDoS attack, denial of service attacks, there is now carriers have expanded drastically the amount of capacity they have deployed globally. But this capacity is mostly unused, so they sell it at low prices. Because we can negotiate wholesale capacity purchases from those backbone carriers, we can actually get very good routes over those carriers, which were previously only available for MPLS customers. But MPLS is expensive, it's slow to deploy because you really have to go end to end. It has to be custom configured for specific enterprises. And this is what creates the cost and the delays that customers are experiencing. So the internet middle mile is evolving, you just need to take advantage of it in a very specific way. So you want to avoid the routing on the internet, but you want to take advantage of this massive increase and the price drop of internet capacity. The second element is software versus hardware. 10 years ago, we had to build everything in custom hardware design in order to achieve performance. So everything was rigid and slow. Now we have evolution. There is an evolution in the ability to deliver software-based solutions because commodity hardware is so much more powerful, and there are innovations done at the hardware level, the chipset level, such as a capability known as DPDK, which allows you to run 25 times the packets on a standard Linux box compared to what you could have done without those capabilities. So software, standard hardware, and innovations at the chipset levels allows us to deliver routing capabilities that previously were only possible with custom hardware. And the last element is the evolution or the emergence of managed services. The cloud enables managed services. We have shortages of people, shortage of expertise. So we go into shared infrastructure, shared resources. We get MSSPs to help us do the expert work that it's hard for us to do in-house. What we previously did is we had to hire people and own the infrastructure. Although owning the infrastructure is not a competitive advantage. It's not why we are in business as enterprises. So those three trends basically enables us to put together a service offering that was simply not available before. I want to close and open this up for questions just by summarizing the three benefits of the architecture that I've outlined. The first thing is the low latency and affordable network. We have low latency internet-based infrastructure because we control the route of the middle mile. That's actually a very important point. If you control the middle mile, you know what the route the packets will take, and you can attach them to SLA-based capacity. You basically can create a network that has MPLS-like latency. And if you don't use MPLS, we make it affordable to you to leverage those kind of agreements that we have with our tier 1 backbone providers. Next, we eliminate infrastructure. If you have your firewall in the cloud, and you can do one optimization in the cloud, and you have sophisticated security capability in the cloud, you simply don't need branch office equipment in the same way you did before. And in the process, you eliminate backhauling because you simply uplink from any location to the Kato cloud, and you don't backhaul anymore to headquarters or to the data center, especially if you try to backhaul over long distances. And finally, we democratize the network. We basically treat equally all the different elements. You have a secure tunnel from your mobile users, from your cloud infrastructure, from your data center, or from your branches. So now you can actually apply a uniform policy across. And this is why the solution that we propose doesn't try to think within a silo on a very limited problem, for example, such as MPLS cost reduction, but really try to rethink the architecture that is needed to support this next generation secure network for the enterprise. I want to thank you for listening here. What I'd like to do now is to pose just last final poll question, and then we will open this up for questions from the audience.
Okay, so Jim, Ishai, thank you for your great presentations. For the audience, if you had questions, we will soon start with the Q&A session. You should now see our last poll. And while we're waiting for the last attendees to answer this poll, I want to share some handouts you can download from the handout section on the right-hand side of your screen. So please help yourselves and download our most recent ebook, MPLS, SD-WAN, Internet, and Cloud Networks, Understanding the Trade-offs for Your Next Generation WAN. There's also the Kato Solution Brief and a video demo of the Kato management application. Okay, so I see we have tons of questions, so let's just start with the Q&A session. First question is, how are you different from an SD-WAN solution?
So I'll take that. As I mentioned, SD-WAN is really focused on enabling offload of MPLS circuits to cheaper internet links, but it's really a very limited step within an overall vision that is targeting a migration of MPLS, which requires the control of the middle mile. So this is one aspect. And the other is really expanding the scope of the WAN beyond just branches to mobile users, cloud-based infrastructure, and cloud applications, and of course, embedding security into it. So the overall cost reduction impact, and this is the poll question that we have here, is substantially larger with the cloud network from Kato as opposed to SD-WAN.
Okay. Next question. Which part of the globe is your global network covering?
So right now we have about a dozen POPs. So I'll just list the main one top of my head. We have a POP in Amsterdam, in Frankfurt, in Ashburn, Virginia, which covers New York, in Chicago, Dallas, Los Angeles, Hong Kong, and Singapore. And we are rapidly deploying more and more POPs. We are covering some areas such as Brazil, for example, with Amazon-based POPs, virtual POPs, but the intention is to build a pure physical infrastructure to make sure that we maximize the throughput and the performance of the solution.
Okay, great. Maybe last question. How are you different from Zscaler?
So Zscaler is basically is a cloud-based security solution. There are two main distinctions. One, Zscaler does not support wide area network traffic or security. It's really internet-only solution. So if you actually want to replace a firewall, you need to handle both wide area network traffic and internet traffic. So this is an area where we can have a bigger impact on the organization. Of course, it doesn't address the latency challenges that were a top issue for this audience on the poll. And ultimately, that's very similar to what I've discussed before, which is it's solving a very specific problem within the overall enterprise context, but it cannot really eliminate existing equipment that you have in branch offices. What it does do well, and we can do too, is to provide direct internet access from branches that do not currently have a firewall. You can basically direct internet traffic to the Kato cloud. You can direct internet traffic to the Zscaler cloud, and we both will handle that. So that's the question about Zscaler.
Okay. Okay, we actually have a lot of more questions, but I think our time is up. So for anyone that didn't get any answer for his question, we will follow up and we'll answer to you privately. I would like to thank everyone again for joining us today, and of course to Jim and Ishai. You will all receive an email with a link to view this webinar again within a couple of days, and we look forward to meeting you again on our next webinar. Thank you, everyone.